Hi, Joanne. I'm going to do numbers 2 and 4 for you here, and hopefully it'll take care of your questions that you have on these. So for the first one, number 2, they want you to write the coordinates of the vertex of the parabola. So let's fill in the table first. If we put a negative 2 in here for x, we could extend these out and just do the work in here. So we'd have 3 times negative 2 squared minus 3. And when you're dealing with those negatives, make sure you use your parentheses if you type that into a calculator or something. But negative 2 squared is 4 times 3 is 12. And then you subtract 3 and you get 9. So if negative 2 goes in, 9 comes out. So we're right up here for that point, negative 2 comma 9. And the next one, if I put a negative 1 in there, I square it, subtract 3, multiply it by 3, subtract 3. So I squared negative 1, that gives me a positive 1, times 3 is 3, minus 3 is 0. So at negative 1, I'm down here at 0. Add 0 in for x, I'm going to have 0 squared minus 3. So this gives me a negative 3. So 0, negative 3 is on the parabola. And then putting a 2 in for x, I'd get 3 times 2 squared minus 3. 2 squared is 4 again, times 3 is 12, minus 3 is 9. So at x equal to 2, I'm up here at 9 again. So it looks as though this y-axis is our axis of symmetry. And if I would put 1 in there, I would probably end up with 0, which I do. So that's another point. So those are your points, and you can see that the vertex is the lowest point in this case, and it occurs when x is equal to 0 right there. We get negative 3 for y. So is it concave up or down? It's concave up. So you can circle that. Does it have a maximum or a minimum then? It would have a minimum since it's going concave up. That's what that means. Write the coordinates of the y-intercept. This is the y-intercept down here, where I'm highlighting in red. Where the parabola crosses the y-axis, that's your y-intercept. So an x-coordinate is 0, so you'd have 0, negative 3 there. And then write the coordinates of the x-intercepts. There's 2 of them. One occurs at negative 1, because y is 0, and the other one occurs at 1, because y is 0 there also. So just keep in mind that if you do have x-intercepts, your y-coordinate is 0. And if you have y-intercepts, your x-coordinate is 0. And then it says, give the coordinates of a point that is symmetric to the point negative 1 comma 0. And I guess I've already answered that one. 1 comma 0 then would be symmetric because it's right across the line of symmetry here. The line of symmetry in this case is the y-axis. And so the point across from negative 1, 0 is 1 comma 0. And sorry about the bad graphing there. It's a little hard with these stylus, but hopefully you can see that. So number 4, then let's go ahead and put some points in here. You always kind of want to know what's happening around the 0, around the origin. So I recommend putting points like negative 2, negative 1, 0, 1, 2, something like that. And if I do put negative 2 in, I get negative 2 squared minus 4 times negative 2 plus 4. And if you do that on your calculator or in your head or whatever. Negative 2 squared is 4. Minus 4 times minus 2 is going to be a plus 8. And then we have plus 4. So we have 16 there. At negative 1, we'll square that, multiply it by negative 4, and then add 4. So if x is negative 1, we get 1. And then this right here gives us plus 4. And then plus 4 more, that's 9. At negative 1, it's equal to 9. I'm going to keep erasing these as I do them, just to make it not so messy. Then as, whoops, then, oh geez. As we move down, if x is 0, I'd have 0 squared minus 4 times 0 plus 4. This is all 0, so I just get 4. At x equal to 1, let's see, I'm going to put 1 in there, square it, minus 4 times 1, and then plus 4. I'd have 1. This becomes negative 4. Negative 4 times positive 1, plus 4. So I just get 1 there. And let's see, putting 2 in for x gives me 2 squared minus 4 times 2 plus 4. And so that gives you 4. This part gives you negative 8 and then plus 4, and we get 0 there. So negative 216 is way up here somewhere. Negative 1, 9 is right there. 0, 4 is right here. 1, 1 is right here. 2, 0 is here. Let's just see what happens at 3. Just to see, that just gives me, it looks like the 2, 0 is going to be the lowest point, the minimum. But let's take a look for sure. If I put 3 in there, I get 3 squared minus 4 times 3 plus 4. So this is 9 minus, this much gives me 12, and then plus 4. That's 9 minus 12 is negative 3, plus 4 is 1. So I was right. I'm going to go back up to 1. So here we have this parabola that goes down, hits a minimum at 2, 0, and then starts going back up. So 2, 0 is the vertex. It's concave up. It has a minimum. The y-coordinate is at 0, 4. And the coordinate of the x-intercepts, it doesn't have to have 2. In this case, it just has the one x-intercept, and so that would be 2, 0. And again, if it's a y-intercept, your x-coordinate is 0, and if it's an x-intercept, your y-coordinate is 0. Now, if this is all a little overwhelming, doing this on your own, type this into Desmos and get your table that way. So if I go over to Desmos, let's see, it's x squared minus 4x plus 4. Just quickly, I think I have something in here now, but no, I don't. So I have x squared plus 4x plus 4, is that correct? No, must be... x squared minus 4x plus 4. So take a look at that again. There you have it. And so now you can clearly see the x-intercept is there, the y-intercept is there, a point across from where, I think that's all you needed actually, yeah. So that's another option, is to always check your work with Desmos. So I hope this helps. Take care, and thanks for asking the questions.